Welcome to RISK66 accelerated training video on volatility of losses at different confidence levels. I'm Tim Coomer. Let's get started. The projected loss pick determined by an actuary provides the expected or average value of losses for the projected policy year. It is also important to understand the volatility around the projected losses. A confidence level analysis demonstrates how actual losses may vary from the projection and enable decision makers to assess the risk involved with their loss pick. For example, an actuary may determine that the projected losses for the upcoming policy year are $1,870,000. This estimate is the expected value for the projected year. Ideally, the estimate would be based on actual loss history, where losses for historical years are adjusted to an estimated ultimate value, trended to cost levels expected for the projected year, and adjusted for changes in exposure. See our projecting losses video for a more detailed explanation. However, the probability of losses being exactly $1,870,000 is very small. A more useful way to look at this projection is to define the probability or the confidence that $1,870,000 will or will not be exceeded. So now let's look at what a typical aggregate loss probability table or confidence level analysis would look like. Now in this example, budgeting for a loss amount of $1,880,000 should be adequate to cover all losses that occur in the projected period 55% of the time. Now this means that 55 out of 100 times losses will be less than or equal to $1,880,000. Now, larger loss amounts relate to higher confidence levels. For example, there is a 75% probability that losses will not exceed $2,080,000. Note that you may also see this range of losses and their probabilities referred to as the spread of loss. A small or tighter spread of loss may make decision-making easier as the range of potential loss levels is reduced. A wider spread may make the decisions more difficult due to the potential for a very high or very low loss level. While each company must decide the confidence level appropriate for budgeting purposes, a higher level of confidence increases the ability of a program to withstand loss costs greater than expected. Several methods can be utilized to estimate losses at the various confidence intervals. A common method involves a Monte Carlo simulation. This method works by first selecting an average or mean frequency and severity for the projected year using various actuarial techniques. Now see our projecting losses video for a more detailed explanation on that. Historical loss data is then reviewed to determine an appropriate distribution and other parameters such as standard deviation for both frequency and severity. There are several different distributions that are used in this analysis or in a Monte Carlo simulation. The log normal distribution is often used when simulating severity since it is positively skewed. Now, Poisson or negative binomial distribution is often used for frequency. Additional distributions may be used in other cases, such as a binomial distribution to simulate the frequency. A normal distribution may be used to simulate the severity for a catastrophic claim or other low frequency and high severity exposures. So let's look at the simulation process. After the initial parameters are determined, a software program can be used to generate a random frequency and a severity for each of the claims based on the distributions that were selected. The simulated losses are capped at any per occurrence or aggregate limits, and the total is recorded. The process is then repeated a large number of times, say 5,000 to 10,000 iterations. Now, the law of large numbers implies that the average of simulated losses for a large number of iterations or policy periods is a close approximation of the expected losses for the projected year. Once we've completed the 5,000 to 10,000 iterations, the total losses for each iteration are then ranked smallest to largest, and estimates by confidence level are summarized. Now, this aggregate distribution provides an overall picture of the expected losses and confidence level estimates around the expected losses. A limitation of this type of statistical model is a concept known as a parameter risk. Now, it's often not included in the calculation of the aggregate distribution. Parameter risk is simply the risk associated with the possible incorrect estimate of the frequency and severity and other parameters that were used as input in creating the model. Additionally, company information, industry data, and professional judgment are often used in selecting input parameters when sufficient historical loss data is not available. In conclusion, these limitations should be understood and considered when relying on the loss simulation in confidence level analysis. For expanded information, see the resources listed along with this video or contact Sigma Actuarial Consulting Group at support@sigmaactuary.com. Thank you for taking time to watch this training video on volatility of losses at different confidence levels from RISK66.